I don't know if that's focused. Shoot, how do I check? Alright, that's probably good. There. Oh, perfect. Alright, ready? Alright, citric acid cycle. Probably should have cleaned this before I started recording. Anyways, alright, citric acid cycle. Or TCA, tricarboxylic acid. That's what that means, I'm pretty sure, right? TCA.
Yeah.
Doesn't fucking matter.
Okay.
So, obviously, we're gonna see the big picture here is you have insulin, and then when you have insulin, what do? Well, when you have high insulin, it means you have high what?
High glucose.
High glucose, and then what? You have high glucose, what does that mean? It means you have high blood sugar, right?
Mm-hmm. And so insulin helps to try and take that out of the blood.
Exactly, and what's that process? Glycolysis, right?
Okay.
Right?
Mm-hmm.
When you have high glycolysis, what's next? Right?
Gluconeogenesis, right?
Fuck no.
Fuck no.
Gluconeogenesis is basically the reverse of glycolysis. That's what you do when you have low insulin. You couldn't make more glucose.
Mm-hmm. I was just thinking that if you're getting rid of, yeah.
You have high glucose here. No, this is the process. It's like a respiration, right?
Mm-hmm.
So when you have high glycolysis, you're making pyruvate.
Yeah.
What?
Oh yeah, pyruvate.
Where is it going?
You could use it to the citric acid cycle.
Exactly. That's the next step. So high glycolysis, and then next step is TCA. And what do we need for the TCA?
You need pyruvate, and you also need acetyl-CoA.
The big thing is this guy right here. Acetyl-CoA. That's what you need. And this guy, this is actually what starts. This is what starts the citric acid cycle.
Starts it, yeah.
It's not. People think it's pyruvate, but it's not pyruvate. It's acetyl-CoA. So.
Well,
From glycolysis.
I mean, technically, if you had like acetyl-CoA, but you had no pyruvate, it wouldn't start either, would it? So technically, both are true.
I guess you're right.
Anyways.
Alright. Anyways, so from glycolysis, what's the product?
Pyruvate. And
Pyruvate,
also,
right?
Yep.
So this is pyruvate here. This is pyruvate. And so pyruvate gets combined, right? Remember the condensation with what? With what? There's no way you don't know this shit. We just talked about it. Acetyl-CoA.
Okay, well, it seemed too simple, so I thought you were saying something else. But yeah, acetyl-CoA.
Yeah, so pyruvate, right? I'm gonna spell it out here, just for people that don't know the structure. Acetyl-CoA, and then that's when you have the pyruvate dehydrogenase complex, PDC, and the TPP and all that shit, right? And then eventually, what are we trying to make here? To start the citric acid cycle, what are we trying to make?
Wasn't it oxaloacetate or something like that? Or is that the final step? That was something else.
Shoot, I just confused myself.
Or is it citrate?
Right. So pyruvate actually before, oh my god, this is so dumb. Pyruvate doesn't actually react with acetyl-CoA. Before it does that, it gets converted to oxaloacetate. You're right.
Okay.
You're right. Fuck! I just confused myself. So yeah, pyruvate goes to oxaloacetate, and then oxaloacetate
It combines with
Ac-
oxaloacetate.
ac-
Or no.
acetyl-CoA. Right?
Yeah,
Acetyl-CoA.
acetyl-CoA. Yeah.
Alright, perfect.
We just went in a circle. Okay,
Yeah.
there we go.
So before pyruvate goes into the citric acid cycle, something happens. The pyruvate dehydrogenase complex, PDC, and that's when you have TPP, and all the cofactors that we probably don't need to know.
Mm-hmm.
And then you have oxaloacetate, which is, see if I can draw this shit. There. Oxaloacetate. So what just happened? 1, 2, 1, 2, 3, 4. What just happened?
Yeah, the carbon.
Just one?
Looks like it.
Yeah, you're right.
Okay.
Right? 1, 2, 3. 1, 2, 3.
1,
1, 2, 3, 4. I counted that wrong because I
Okay.
went, what the fuck? Yeah, I counted that wrong before. So you're adding, what are we adding? HCO3, right? HCO3 minus, and that's what gives it that extra carbon there.
Okay.
So I'm gonna spell this out. Okay, I'm gonna write OAA, just means oxaloacetate. Boom. And this guy then reacts with what?
Acetyl-CoA.
Okay.
The dude was about to be like, "Are you?"
I would've got so mad, bro. Acetyl-CoA. And this is what kicks off the citric acid cycle. Oxaloacetate plus acetyl-CoA.
Makes citrate.
Yeah, perfect. So now we're gonna make citrate, which is basically this. Citrate. Boom. Right? Next thing that happens is the isomerization.
Isomerization, and that just makes it isocitrate.
Yep. So the isomerization happens here. Isomerization. And then the enzyme here is aconitase. And then that makes it, so basically it takes this OH to this side. That's all that changes. This OH goes from here to here.
So not much.
Yep. So now we have isocitrate. Oh god, I hate drawing this. But drawing it is actually the best way for me. So the OH goes here. Perfect. And this is isocitrate. Next thing that's gonna happen, you're never gonna guess. That's the biggest step of the citric acid cycle. The next thing that's gonna happen.
Are you asking for like the product of it, or are you asking for like what brings it to?
Yeah, I'm asking for the product. What do you think?
It's like alpha keto something.
Mhm.
I'm gonna look at alpha keto glutarate.
Right. Perfect. But guess what also happens is we're gonna lose the CO2 group here. We're gonna lose that group. Okay? This is why you should never memorize any pathway. If you can draw it out, it's so easy. You're gonna lose that, and this guy is gonna get oxidized. So you're gonna have this. Bop, 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 bop. Oxidized. You see that? What's that guy called?
That's the alpha keto glutarate.
Alpha ketoglutarate. Alpha, I'm gonna write kg because I'm not gonna write the whole thing. Alpha ketoglutarate. Perfect. And then from here, what do you think is gonna happen? Because we have to make GTP in this process.
So since we lose the H on that OH on the bottom, we also get NADH out of this, right? We get our carrier.
Yeah, because we had an oxidation from this guy to this guy, so So the NADH is gonna be what? Oxidized or reduced?
Reduced.
So you're gonna have NAD plus to NADH plus H plus. But now the next step is we're trying to make energy. We're trying to make GTP from this. How the fuck are we gonna do that? How?
Are we going to? We need to get more carriers out of it, don't we? Or
I mean,
in a sense.
I mean, yeah. But the big thing here is what we're actually trying to do is make energy, free energy.
So are we gonna
And that
reduce
free
it?
energy is what gives GDP the power to go back up to GTP.
Mm-hmm.
So we need to make this guy really unstable. It's kind of like glycolysis. You have the 1,3 BPG
Mm-hmm.
goes down. That's really high
Yeah,
energy.
high energy. Then you
Goes
break
down
it.
to 2 PG, and that releases energy and takes ADP to ATP in glycolysis. So what we're gonna do, we're gonna make this guy a thioester, and that's really high energy. So it's basically this. Shoot, let's see if I remember this. Let's go away. Perfect, right? So we're also losing the CO2 here. Is this correct? Does that look right?
So I'm looking at this succinyl CoA, lose the CO2,
Mm-hmm.
and then we get an NADH out of it.
Yeah. Right. So there's also that's also an oxidation. So the NADH, the NAD is going to get reduced here as well. So NAD plus to NADH, NADH plus H.
You might want to consider moving the phone if it's not capturing.
Is it capturing?
I mean, it's recording, but I don't know if it has it in frame.
Bro, I don't fucking care anymore, bro.
Okay.
Should be fine. But we can take a picture after this.
Yeah, yeah.
So when we have this guy that's really high energy, this guy, by the way, is called succinyl-CoA. Succinyl-CoA. And so succinyl-CoA is going to come down here, and we're going to have this guy. It's called succinate.
Succinate.
Yeah, succinate.
And then we apparently also
He
get.
sucks and he hates people, bro. Or he sucks and he hates people.
Yeah.
He's gay like that, bro.
What? And
Succinate.
apparently we also get GTP to ATP.
Yeah, no, that's no. We talked about that, bro. Why? Look.
Because we're breaking it from a higher energy to a lower energy. and
So
getting
obviously, that gives us the free energy to go from what?
GTP to
GDP.
DP. It says here GTP.
No.
Or honestly, it means we get GTP and ATP out of it.
We get. I mean, some people call it ATP. I mean, in the grand scheme of things, it doesn't matter.
Mm-hmm.
But it goes from GDP to GTP. That's what this does. Okay? Now, the best part. My best part about the citric acid cycle is this enzyme here has a very nice name. Succinyl. We probably don't even have to know this. Succinyl-CoA synthetase. Not synthase, but synthetase. That's my best enzyme ever.
Why?
I just like the name.
Okay.
Succinyl-CoA synthetase. Not synthase.
I mean, you do you.
Succinyl-CoA synthetase. And so you have succinate. What does succinate go into? Don't tell me. Let's figure it out. Right. So I'm gonna have this here. And this is why I never memorize. I just draw the entire thing and try to figure it out. So you have this here. You have this here. There's gonna be an oxidation. There has to be an oxidation, because what the fuck am I gonna do with that? I'm gonna oxidize this. And we talked about this shit. What oxidizes CH bonds, single bonds to double bonds? Is it NADH
Is it FD?
or is it FADH?
It's FDH, right?
It's FADH. Remember?
I don't remember specifically mentioning that like FDH is specifically for the double bonds.
It is.
But okay.
Now you know.
Now you know.
So, is FADH gonna get reduced or oxidized?
It gets reduced, right?
Yeah, because this guy gets oxidized, so
Mhm.
this will get reduced. So, FAD, shoot.
Reduced to FDH2.
So FAD gets reduced to FADH2. Perfect. And this guy's called what?
Suck at something.
No, he doesn't suck. He stopped sucking here because he hates them.
Okay.
So he's not gonna keep sucking if he doesn't like you.
Well, I didn't memorize it, but I looked at it. Fumarate.
Fumarate. Is it fumarate or fumarase?
It says fumarate.
Fumarate. Oh, that makes sense because there's a negative charge. It's a fumarate. And the enzyme's called fumarase. I'm pretty sure.
Makes sense.
No, it's not. I lied.
Why would you do that?
It's not called fumarase. It's called. We don't have to know it. Let's not go into that.
Yeah.
But where is this also found? This entire thing. Where is this found?
Good question.
Electron transfer chain. Complex 2. You probably don't remember that now, but when you're studying,
Eventually, when I get back to studying that bit,
you'll
yeah.
be like, oh, that's
Well,
what he was talking about.
Because he's a bitch.
You're a bitch.
What?
Alright. So we have fumarate now, and so fumarate. What does that go to? Let's see. Goes to this.
Does that go back to oxaloacetate, or is that a later step? Oh, that's late. There's
Yeah.
one more step. Yeah.
Eventually it does, yeah. Well, think about this. So you're right. We're trying to go from here back to
The starting point. To keep
Oxaloacetate.
going. Yeah. There was just a few more steps I forgot.
right. So think about this, Ethan. And by the way, this is the exact same thing as this. It's flipped, right? So we're trying to go. You see that it's flipped? It's literally just flipped.
And it's
if
also
you
missing.
don't see it, I can just redraw it.
I mean, it's also missing a third double bond oxygen in the middle.
Exactly. How do we get that?
We have to oxidize it.
So we have this here, a double bond.
Mm-hmm.
How do we get that to get to a carbonyl? We give it water, lots of water. So we're gonna have water here, hydrate, and then we're gonna get the OH here, right?
Okay.
OH.
Okay.
And then, right? Yep, we're gonna get the OH there. Perfect. And then from here, you can probably figure out how it goes from this to this, right? How it goes from, what's this called again? Malate, right? Malate. This is called malate.
Malate, yep.
You can probably figure out how it goes from malate to oxaloacetate. What happens?
The word is like on the tip of my tongue, but it's a process where like you change it. Oh, what the fuck is it called? It's because the double bond is still there, and it like restabilizes to the oxygen, right?
No, the double bond's gone.
Okay, no, it is gone. Okay, I thought it was there. We just hadn't drawn it in.
No, the
Okay.
double bond's gone. Because we added water inside, right? Hydrate, and then we get the OH. The double bond's
Oh,
gone.
then we just reduce it, right, to get rid of the.
We're not reducing it though. Look,
No.
if we have the double bond plus the OH, how many bonds is that carbon gonna have? Like 1, 2. It's gonna have like 5 bonds to it, the carbon. So no, the double bond's gone. How do we go from OH to a carbonyl, bro? It's an oxidation, isn't it?
Didn't I already say oxidation?
Did you?
I thought I did. Okay. Anyways.
No, you didn't. So, maybe you did, I don't know. So when this gets oxidized, again, every reaction where something gets reduced or oxidized happens with something else doing the opposite. So it's always a redox.
Mm.
So something else is going to happen here, which is reduction or oxidation.
Right, well, it's oxidation reduction. Like it happens, both of them kind of happen to one or the other.
Right.
So which one were you asking? Which one
So-
gets oxidized?
This gets oxidized, right? Mildly gets oxidized. So what's
Yeah.
going to happen to the
Reduced.
exactly to the carrier is NAD plus goes to NADH plus H plus boom. And that, my friend, is the citric acid cycle. Right?
So yeah, because it goes back to oxaloacetate, and then yeah. So the whole thing.
What's the citric acid cycle?
Yeah.
Alright.
We take a photo of that.
Alright.
Even though it's already in there, but this is